Hi, I'm Naila Burney, and this video explains my master's dissertation for the course of Sound and Music for Interactive Games at Leeds Metropolitan University. A main challenge in video games is to record, edit, and manage thousands of dialogue lines. The amount of dialogue depends on how many characters there are and all possible behaviors for each one. Having to deal with huge amounts of dialogue is expensive, time-consuming, and there is usually not enough space and RAM for audio, and this might lead to repeating dialogue lines, which breaks immersion in games. This project presents a system that generates fictional languages as a solution that would simplify the processes and reduce costs. Why is it narrowed to fictional languages? Many games occur in fantasy worlds that have fictional characters such as aliens and creatures that require special languages. Also, in some games in which characters are human, fictional languages are used instead of natural ones because they help the player to keep focused without noticing inexpressive dialogue or dialogue recorded out of context. Thus, a dialogue system for fictional language lines is a specific need in the industry. The structure of the system is based on how languages work and creates a series of morphemes, phonemes, breathings or filled pauses, and delays. What exactly does this mean? A morpheme is the smallest unit of language that conveys meaning. Some morphemes, such as cow, can stand alone as words. Standalone and non-standalone morphemes can be combined to build larger words. The second component is a phoneme. Phonemes are speech sounds such as t or k. They are key elements in this project because phonemes can characterize a language. In Polish, for example, the sh and ch are very common phonemes and add a particular seal to the language. In alien and creature dialects, clicks or unconventional noises are the equivalent of these phonemes and are used to characterize and give the illusion of a language. In this project, these type of phonemes will be referred to as unifying sounds. Note that this project does not intend to build fully functional languages, and thus it will not include any type of grammar rules. The next element in the chain is a breathing or a filled pause. This setting can be useful if, for example, you want the creature to sound more casual or maybe nervous. It depends on the needs of the character. Finally, the last element of the list is a pause or a delay. Pauses provide articulation to sentences. Note that breathings also add pauses to phrases. However, suppose that your creature has no breathings. It is then still convenient to add certain pauses to give the impression of a sentence. In short, the main structure of the system is morpheme, phoneme, breathing, delay, and then it starts all over again with new sounds. But this is still not how we speak. We need to build words that flow into sentences. Thus, the system allows to configure percentage of phonemes, probabilities for each type of phoneme, percentage of breathings, probabilities of short, long, or no pauses, sentence length, and question endings. This way, it is possible to create series of phrases that resemble the way we speak. Now, the next big question is how to convey emotion? According to Jocelyn, we can identify emotional tone due to certain behaviors of dynamics, pitch, and pace. The present system was designed based on Jocelyn's charts and focuses on some universal moods that are sad, angry, and happy. It also includes neutral as an emotionless state. These moods, or slight variations of them, are commonly used as voice tone choices in video games. Moods can be expressed on a two-dimensional plane, where the y-axis represents arousal, level of energy, and the x-axis represents valence, positive or negative feeling. In the fictional language dialogue system, the user can choose the mood from a slider that goes from furious to excited. If the user selects the happy mood, the sequence will include files from the happy folder. If the user selects a higher degree of happy mood towards excited, the sequence will include less files from the happy folder and more files from the excited folder. In short, the slider affects valence. All this seems very nice. But how is the result actually going to sound if the audio samples come from different sources? I may have lion samples, gorilla breathings, and frog noises. So how to make everything sound uniform as if it were a single creature? Let's review Ben Burtt's method for creating the languages in Star Wars. He first recorded groans and vocalizations of bears, lions, walrus, and dogs. He then classified them into angry, happy, and inquisitive. He built a word list, modified and processed the sounds with pitch variations, and added different layers of sounds. Finally, he created phrases by concatenating all the sounds. Based on this methodology, the present system allows to add layers underneath the main morphemes and phonemes in order to add commonality and bind sounds together. In order to test the system, 52 participants were asked to answer questions regarding the mood expressed on 9 dialogue samples for 2 different creatures. The first 4 samples correspond to a large animal creature made of big vocalizations and other wild animal sounds. The next 5 samples correspond to a small futuristic alien that were recorded with my own voice. Participants were asked to match a mood with the sound file. The results show that in the first creature, sad and neutral moods were often confused. However, sad and neutral have similar pitch and dynamic qualities. Both have a low pitch range, low volume, and low pitch and dynamics variability. In other words, both moods share the same range of arousal, which means these results are not negative. Similarly, in the second creature, angry was confused with happy, which is apparently opposite, but in truth shares the same arousal dimension. The main difference is the valence. This means that the major problems that caused confusion among contestants were the samples and the intrinsic nature of the sounds. Further improvements of the system include analyzing other elements that help convey mood, such as timbre. Another improvement would be to find alternatives for raising and lowering intonation. For example, experimenting with methods such as form and pitch shifting and granular synthesis. The system also needs specific rules for the pauses so that they do not appear at random places but at n% of a sentence specified by the user. Finally, the system would be more efficient if it had more types of sounds classified into subfolders, such as initializing sounds, connector sounds, and ending sounds, and this way provide more smoothness to the phrases. The fictional language dialogue system presented for this dissertation is still in a testing and developmental stage. However, although the project has wide room for improvement, the process and results can help expand the knowledge on this topic and serve as a starting point for those interested in exploring this field.